since I haven't streamed. I'm reading a bunch of C++ books and doing a course. And I think that the next thing that I'm gonna do is to continue the project that I was doing on the browser, but I think I'm gonna try to do something with C++ because the thing that I don't like about doing it on the browser is that you have to think about the state management of the whole website, and that kind of gets in the way of the actual thing. So I want to see if in C++ it's going to be more direct. And obviously the other reason is because I think that it is pretty important to learn C++ and C and get more experience because it's going to help me become a lot better in everything else. So like doing the project on C++ is going to help me gain some experience. So ChatGPT recommended me these websites. I haven't seen them or tested them, so I'm not really sure if it's gonna be good or not. And I'm gonna try to do the exercises of both these websites here. And if they are shit, then or I don't like them, then I'm going to study, or I think I'm gonna open the book. There's a book that I wanna review, which is the best book that I found so far from the ones I've read. That is Pointers on C by this guy here. And I want to go over the book again because the main reason for reading the books now is to learn more the about pointers, because everything else I think it makes more sense to watch videos. But this book has some really good examples of pointers that are very difficult. So I'm thinking about copying all of them and putting on the IDE and then trying to see if I can spend a bunch of time until I kind of memorize or learn all the to spend a bunch of time on them until I memorize or learn all the patterns. But first I'm going to try to see if the website has good exercises. And the other thing that I found, which I think I did found way before I was doing the website version, is I found a Barnsut implementation on C++. So I think I'm thinking about studying that project. And the other thing that I want to say since the last time I streamed is that I realized that I was just being dumb last time because I was trying to figure out how to make the debugger work with VS Code. And they have this example here, but it wasn't working. But the reason why it wasn't working was because my code was wrong. And the reason why I didn't understand that is because I thought that, like, I obviously saw that there were some warnings there, but it was kind of misleading, I think, the warnings and the thing that I got. So I thought it maybe because of other reasons, but then I figured out that I changed some parts of the code and then started working. But it is kind of, I still don't understand very well because there's several different C compilers. I think there's GCC, then CLang, and G++ is for C++, I think. But for some reason, the compilers have different interpretation of the code, I think, which is kind of weird because it's supposed to be the same language. So the way that it works, the process is first it compiles everything and turns into an object file. And I think this part it does the pre-processing, but I'm not 100% sure. And the pre-processing is just replacing the code with the macros. So macros are just a way to like simplify so you don't have to write the same thing all the time. So it replaces all the macros with code and then creates the object files. And then the second part is the linker, which is a separate thing from the compiler, which is the thing that is going to connect all the object files, so the function declarations with the definitions. And then after that, it creates the executable. But for some reason, different compilers have different interpretation, I think, of especially the paths. And then I watched another course and kind of did a starter project, which is the one that I think I'm gonna work on now. So I'm gonna try to create a graph visualization out of the compilers or interpreters. But first I'm gonna study like I have to read all these books and I'm gonna study the Python interpreter again because I want to understand the generation of the deterministic or non-deterministic finite automata. But this one is good because I think that's shouldn't be that hard to change this, hopefully, to put external libraries here. So the idea is to put this one. Let me do the exercises, then I think about this. Problem is that this one might be just... might be just text. Also, I want to figure out the... maybe I should do this before I even do all this other stuff. Or I'm like feeling that this is not going to be very good. It's just going to be a bunch of tags for the most parts. Like instead of pre-code camp style things. So maybe I'll look into the other one first. But then I'll probably copy all the exercise or all the examples on the book into the IDE and then try something. I was thinking about doing lead code challenges as well, but the points I don't want to like, because the point of doing this now is more to gain some practice with pointers and really understanding pointers, because I know it's gonna help when debugging everything else. So I don't like this that much. I'm just gonna check the other one. If I don't like, then just gonna copy the stuff from the book. In C, the strings are an array. So a string, everything, and this is kind of the thing that I suspect is wrong on this one, but I'm not 100% sure. That I've been trying to debug. The main reason why I want to debug is just to understand like exactly what it was going wrong, so I got the fundamental like understanding of how to think about it. But now I think that the problem is not, but obviously I'm not 100% sure, but it seems like the problem is not that the way that I'm pushing here or creating the token. I think that, yeah, it is the way that I'm creating, but not pushing to the vector here, which is a struct. I think is more the way that I'm connecting this to here. So what I'm gonna try to do is just comment this out, but I'm pretty sure that, not pretty sure, but I remember trying to comment a bunch of this stuff out and I was still getting a problem. So the issue is that, at least the way that it is now, I'm not getting a segmentation fault when it gets to the point of this function. So it runs everything fine, but I do get a segmentation fault when it gets time to save everything to JSON in the other function. So when I try to access the current node from the vector, it says that it gives a segmentation fault, which is kind of weird because it seems like it is appending or pushing the nodes to the vector. So I suspect that the problem might be this one, because here, like I have a const to const char to a pointer in the definition of the struct, if I remember correctly, and on the definition of the token is also maybe so I'm not 100% sure, but I think it's going to be this one in the way that I'm doing there. So I have a const char pointer. So let me see. Yeah, whenever the const is before, it means that the pointer is pointing to a constant value. But if the char or whatever the Not sure how to say that. Specifier is before the const, then it means that the pointer is the const. So it's kind of confusing. I spent a bunch of time trying to remember this as well. But basically this means that you have a variable that is pointing to a constant variable, which is going to be the char. If it was the other way around, then it would be a constant pointer. So it would be, yeah, a constant pointer if you declare like this. So I have a const. So this points to, this is a pointer to an array that is going to contain the string, as far as I understand now. And what I'm doing here is making the label one from here, which is also a pointer to a const, which is going to be the array that contains the char, equal to the other one. So what I think is happening here is just that I'm reassigning the value of this, or assigning the value of this pointer, because on the declaration doesn't have any value, to the same value, to the same place in memory that this one is at. But the problem is that on this loop here, it pushes this one to the vector, and then when it does that, it removes it changes the place in memory, and I think that at this point I lose the pointer on the other one, but I'm not 100% sure if that's what's happening, because on the other iteration of the loop is gonna reassign the value, I think. But if it's const, I'm not 100% sure if that's the reason, because maybe it's not what I was intending to do, and I think it is wrong to do it this way. But maybe it's still supposed to work, because even though you're pushing to the other vector, maybe it still allows you to point with the, like, it still allows this one to point to this pointer on the vector, if that makes sense, even though like it changed place. But I'm not sure about this. So what I'm thinking about is just commenting out to see if this is the problem in the first place, but I don't really know. And that's the whole reason why I got into this place that I'm at now, trying to read all these books to see if I understand more, like, exactly what is going on. So one of the biggest things that is kind of confusing to me as well, as far as I know right now, like, there's a difference between using this pointer operator on the left hand side and the right hand side, and they call by this name LHS and RHS. So like I think that if you use this to declare to initialize, then what you're saying is that you're pointing, like you're creating a pointer to this place in memory. When you use calloc is going to be on the heap, which means that when the function goes out of scope, you don't lose the value because the value is on the heap. So if you don't do it this way, then it breaks the code, because you lose the value as soon as the function ends. So this is the reason which you declare like this. So I'm creating a pointer to a place in heap. But if I reassign this to another value, then I think that has a different meaning, and that's the thing that is kind of confusing. So let's say like I do this like 0. I think what this is supposed to do is gonna take the value that this is pointing to, so this place here, and it's gonna reassign the value to 0 instead. So now you're not accessing the pointer anymore, even though the what you write is the same. So this is kind of confusing to me. So I need to clarify this as well. Let me see. I took some notes, but the stuff that I have to review. It's pretty much like this, but I'm not really sure if I'm gonna be able to find videos about it, but probably on the books. They're gonna talk about it. And then obviously on C++ is different than C. Not, it is very different, but it's just building on top of it. So on C++, apparently they, like on the standard library, they have they create a struct that is a string that's part of the standard library, and pretty much they just automated the process of manually allocating, having to allocate and reallocate memory to increase the string, because every string is an array, and every character is going to be one index of that array. So usually when you create a string on C, you're creating a pointer to an array, and then you have to like recalculate the values every time that you want to change the string, which probably got very annoying, and then people created C++ because of that. So it just automates the process on the structure thing. Maybe it's not a... It is a class, not a structure thing. But a class is a struct pretty much. The only difference is that on the class, I think, on the struct everything is public by default, and on the class, not necessarily. So I think that's the main difference between the two. I don't know how to increase the size of this. Okay, so what do I have to create a partial local variable? So is it to increase the value of n by 1? So this is the part that it kind of gets confusing. I think the most challenging part is this stuff about is the operations that you can do with pointers, and it got very confusing on the book when he uses the plus plus and minus minus, which apparently is used very often, and especially with strings and arrays. Because then depending on the place you put the parentheses or the reference, it gives a different meaning. So it's kind of... So here, the way that I'm thinking about it is like this, but I'm not 100% sure like if it would work, because like in my mind, I'm dereferencing the pointer, so it's gonna access the value. So here I'm just pointing to the address of n, I think, and then I dereference and increase the value by 1, but not sure that works. Hey, what's up? Okay, so apparently this works. So the other thing that, so the reason for having pointers, so there's two things, also two things that I learned. That the main reason for having pointers is because the structs and arrays, like every time you pass a value to a function and it's not a pointer, it's gonna copy that value. And the bigger the value is, the more costly it becomes, obviously. So the main purpose of the pointer is so you can pass by reference, and then you're just passing the pointer, and then you change. So the other biggest thing, or main thing that I learned is that you can create function pointers, which is just a pointer to the place of the function is at in memory. And I thought about it. I think that it is the same as callbacks on the higher level languages. So callbacks are just pointers to functions. And then I asked ChatGPT, and it says that it makes sense. But I'm not 100% sure if that's how it works on the high level languages. But I think it is. So callbacks are just pointers to functions on the other languages. Hey, nice, nice. What I have learned, it allows to manipulate value of a variable from other functions. What do you mean? The pointer to functions? Manipulate value of a variable from other functions. Or passing by reference. I think you mean passing by reference. Yeah. Oh, and this is the reason why the guy did the vector library here. I think this vector library is probably very similar to the way that the strings work on C++. There is just a bunch of functions that's gonna reallocate everything when it has to. So when you're pushing values, it's gonna check to see if the boundary got there. And also there's a difference between pointer arithmetic and data arithmetic. So when you have a pointer, you can add or subtract, but the way that you add is just gonna change it's kind of like changing the index of the array. So like, because in C you can only declare arrays with that have the same data inside of them. So either integer, longs, or like booleans, that kind of thing. Because of that, the size of each index is going to be the size of the data type you declare the array as. And doing pointer arithmetic is just like moving the pointer as many bytes as that type takes. So it's pretty much just moving the index. Have you read K and RC programming book? This one? Kenneth Riff? Not really sure how to say his name. I read it really fast because there's so many other stuff that I want to read all of the books first, and then like I was doing a course as well, which I don't like, didn't like, to be honest. It's just a bunch of fluff on the course, so it was like the course could be like 2 hours long, and it was like several hours, so I kind of regret it. But I am thinking about getting these examples here from this book, because so far this has been the best book for understanding pointers, I think. But I haven't had read many, and some of them I got online and I didn't have the whole book, so I just read a couple of chapters that were available. So I should have done this as I was reading this book, but I didn't realize. I didn't think about this. Maybe I'll leave this for... I think I'm gonna read all the other books. Like, there's so much stuff to... The problem is that some of these books are like 10, 12 hours long, because they have so many pages. So it's gonna take me a lot of time to go through all of them. So I'm just streaming today because I spend a bunch of time without streaming. So, but I like, the only thing that I have in my mind right now, like when I start something, I want to finish. So I just want to go over all this stuff. So it's gonna take a lot of time. But I'm thinking that for the C++ books, I'm just gonna start going straight to the pointers part. There's also some other stuff that is very confusing. So one of them is operator overloading. So this is all for C++, and does not happen in C. But it pretty much allows you to change what the operator does. And Python has something similar, which is the dunder method. So the add dunder method allows you to overload the plus operator on the class. It's pretty much the same concept, so but it's kind of confusing the way that they declare the everything. Then there's this stuff as well, which allows you to declare multiple functions with different types. It's not that hard, polymorphism. I think the biggest thing is templates. I forgot to put here. And these smart pointers as well, that is very confusing. So templates is similar to TypeScript, but it gets very confusing. Like I don't really understand very well. I wish I could expand this thing here. So what I think what I'm gonna do is just do this later. So I'm gonna read this book again, I think, and then the second time that I read, I'm just gonna like grab all the codes as I read, because it's probably gonna be like better than trying to parse everything now again. So just gonna see. I'm gonna try to solve these puzzles here, and then if I still like have some time, then I'm going to study the other projects from Barnstadt. Maybe actually I'm gonna try to solve the debugging thing there. See what happens. But first let me try to solve these exercises here. I think I'm gonna be right back. Was that the only exercise for pointers? Oh, it has name and age. This is kind of tricky. So age can be I don't remember if C has short int and other types of integers. I'm pretty sure that C++ does. But I'm just gonna leave it like this, and then how do I do this one? Maybe like this. Yeah, it's probably. There's a lot of stuff in my mind, so it's kind of hard to think. There's a lot going on. I was wide. This is another thing that is kind of confusing, is that whenever I have the function here, I'm never really quite sure if I should dereference again or just do it with the P, but right now I think I should dereference, but it's kind of weird because it's already dereferenced here. But no, I think it is, yeah, you should dereference. I remember now. But it's kind of confusing, to be honest. Because like the type already says, but I think it is just confusing because it's the definition of the type, but what is happening when it is running is that it's passing the pointer. Like it's passing the point, so you have to explicitly dereference the pointer to change the value. But that's probably how you do it. Arrow operator is the beauty of pointers. Oh, it has to be. So, oh, this is the arrow. That's what I mean. So there's two different ways to do it, I think. Like one is to. I don't remember really well now. Oh, I think yeah, is like this. And the other one is to use the arrow. I'm gonna try like this first to see if it's wrong. Is correct. Yeah. But the arrow is just for simplicity, which is kind of confusing as well, to be honest. And the more that I learned C++ or C, the more I understand why people created Rust, because I think it solves most of the confusing parts. But I still think that I want to learn C++ and implement C++ on projects, and it seems like C++ is the one that is used the most for gaming. So the main thing that I'm interested on right now is just understanding how to use C++ to create the graphic user interface and then creating the graph data structure with it. And then maybe I'll move to Rust once. Yeah, but I'm not really sure if it's Rust. Rust is gonna be, but I know that like from what I've seen from X, that it looks like they're using Rust on the backend. So I think Rust is probably gonna be more widely used. So, but it's kind of difficult to decide which one to go with. Obviously, I'm gonna do C++ now, but it's always a tough choice. Don't dereference it, then you are actually modifying the address of variable. In order to change value, you need to, yeah. But that was just another way to dereference. So like the arrow is syntactic sugar to write the same thing that I did there with the pointer, with the parentheses. Blah, blah. These exercises are not very interesting, to be honest. I was hoping more for exercises that are heavily related to pointers. New point struct, which my point points to here. So yeah, I guess that like if I want the pointer to point, then I don't do reference. So I just do this and then malloc. And then size of probably. Yeah. Or my points. No, size of per. Yeah, it has to be no size of points. Because it's the thing here probably. Yeah, but no. So it looks like I do need to put this stuff. So the main thing that I need to clarify is this whole thing about the difference between left-hand side and the left-hand side and right-hand side. Not sure if it's hands. So I'm gonna ask ChatGPT this. Kenneth's book has some stuff about this, but I don't remember very well. But I guess that's what's confusing me the most. That and whenever I have multiple different pointers, so pointers to pointers, it's also hard. So the question is why use this stuff here? Because obviously you're creating the pointer, but then as far as I understand, on the right hand side you're supposed to get the value when you use the like you're dereferencing the thing, but maybe not, maybe it's different actually. So I'm gonna test, like, if it works then I'm just gonna put this on ChatGPT. Let me ask the question of the other one first, then I ask about right hand values and left hand values. Just to specify the type. So I guess you do this whenever you're using malloc or kloc because it has to know the value in order to know how much is gonna allocate, how much memory is gonna allocate for that. But actually, I'm not really sure. Maybe it's whenever you wanna reallocate memory. Yeah, no, it is. I think it has to be. Like, it has to both know the value and the quantity, I think. So what you're passing inside is the quantity, because you can pass more than the size of the 1 point when you're initializing. I think that's what's happening. And then the type is probably gonna determine like how many blocks you put for each thing. So I think I get it now. So in this instance, this doesn't have anything to do, just specifying which type it's gonna be. But it's kind of weird actually, because it's not really the type of points. Like, I'm not creating a malloc for storing pointers. It's supposed to store the point itself. Oh, so is the type that it returns. So yeah, the type is for the variable on the so that the compiler probably knows that the type of the variable that the thing is equivalent to. So I think I understand this now. So not to specify the size, the blocks of memory that it's gonna assign, it's just the type that it's gonna return. Yeah. Still not 100% sure. So obviously I'm gonna have to like review this again. And this one is starts to get hard. So I'm assuming it has to be. But I'm not really sure. Like it's gonna be using this, like this and this. But I'm not really sure what the type's gonna be. So let me go back. It's gonna be his name probably. The other thing that I don't know really well is like how is it possible that you can use the star operator to multiply things and also to dereference them? I'm curious about how the compiler knows. Like obviously it's gonna be, I think it's gonna be on the grammar part, obviously, because like it's when you build the sentence that the difference is gonna play out, I think. But I don't understand really well how is it possible to. It's probably a rule in the grammar. That's probably how it happens. But I don't understand the nuance of it. And here I'm not really sure because it's different than the example here. So like maybe I should multiply I and j because it has to be like on your mind is gonna be an array or a matrix of columns and rows, but I think on memory is just a straight line. So the way that you allocate enough is just by multiplying the size, I think. So you're getting the area of the matrix, but in one line. And it has to be a pointer to a pointer because what the array is gonna have contain pointers. So it points to the array which contain pointers to the values. But I'm not 100% sure that's how it works. Because you have integers, so it doesn't make a lot of sense. It would make sense if it was arrays of strings, because then each one is a pointer, but if you have arrays of integers, then what's the point of creating a pointer to a pointer? Also, just doing this. Oh, I guess I get it, because it is an array that contains pointers to other arrays. So that's the reason why it's doing like this, I think. So each one of the rows contains a pointer to the column, I think. Not sure if I understand this one. Oh, I need to assign these to numbers. Six memory slots to store those 6 numbers. Over here there's 7. I'm not sure. I'm not sure if I'm supposed to make both of them equal to 6. But like it's gonna be a pain in the ass if I have to manually. So obviously I can create a loop and add, but I'm not really sure what they want me to do. Because then it would be just this same thing here. Maybe I'm supposed to do it inside of the loops here. So it's saying I equal to 3. So I don't know. I'm kind of confused here. Not really sure what to do. I don't know how many numbers I should put here. Thinking about it this way is always confusing to me as well. Like the indexes here. I understand the concept obviously, but the index is always confusing. So I think that's by this is like three by three. It's taking the first row and then first column. And so there are 3 rows. I don't understand it, to be honest. And for only 3 rows. This, I think it has to be 3 by 6. So this is supposed to be a place in memory that is gonna hold pointers to the other arrays. So maybe the declaration here is wrong as well. It should be maybe just like this. I was thinking about it in the wrong way. Because the way that I was thinking about it is that this p number is going to be a matrix. But I think what they want me to do is that it's going to be a pointer to... Yeah, it's going to be an array that contains pointers to another array. The first element is malloc. Also, I think what they want me to do is just copy the... Because you need each one to have a... to have memory. So one thing that I don't understand here that is coming on my mind is that how is it possible to initialize like this? Maybe they want me to change this as well. Because if it's just one int, then it's not going to be able to hold the other ones. Unless you reallocate, but it's not a pointer is going to return the pointer to the integer. So it's going to return a pointer to a type integer. But it's not a pointer. So I think that is probably 6 here. That I have to, like, instead of 1, I have to put 6 for each one. And then I just have to change here so I have all of them, maybe. I think the exercises are good. The only downside is just the size of the stuff. Wish I could expand this. Maybe here. No. It's good because it forces me to think about how to do it. Obviously, if I can do it, just gonna look at the solution and go to the other one. But I want to spend some time forcing myself to think a little bit. So here, just doing a nested loop to go over all the elements. It's gonna print by. Oh. I think to free. I don't remember really well. I should probably do the other. I think I can loop. I can free just by. Because the only thing that you need to free is the malloc that you assign, I think. So just calling on each one probably should do it. So as far as I understand now as well, whenever you use the subscript operator, which is the name of the square brackets, what you're doing is just dereferencing the pointer. So it's the same thing as dereferencing. So as far as I remember, I'm not really sure. So like doing p numbers I there is the same thing as doing, I think, the pointer to p numbers plus I. So I think this is the same thing as using the subscript, but it's just syntactic sugar. Because this is gonna add I to the p numbers to the pointer, which is the same thing as moving on the indexes on the array, and then it's just gonna dereference to get the value, and the value is gonna be the malloc, I think. So yeah, not really sure if I should dereference here because it's a pointer to a pointer, but I think not. Probably just put the name. So it wants to free everything. Yeah, probably. These kinds of things, that's one of the reasons why I want to do this exercise is because, like, especially with matrices, I get it, but I never want to spend the time thinking about it because it's just like annoying. And but I understand, I think, the concepts behind it, but I don't just want to force myself to think. Which I think is natural as well. Like everyone does that probably. No, probably I think everyone does that. Just the way that your system works, or human beings' systems work. Recursion is even more difficult on C and C++ because of the pointers. So this is probably going to be hard. I think we're going to be right back. So the type has to be. How do you do how do you return the function itself? So it's just gonna be integer. Because I guess you always have you always need the base case, so the type's gonna be the type that the base case returns. Just gonna copy there what they have. For these kinds of things, for example, I don't like to spend time thinking. I think it's just waste of energy. It's part of the reason why I don't like that much to do lead code problems. But if you could remove get to the core of it, I think it's good. But spending energy trying to think about specific problems, I don't think is very good. It's like kind of inefficient. I think it's better than nothing, obviously, but inefficient. So if it's less than 1, it's just gonna call itself with the next one and the other number, and just summing. Shouldn't it be multiplying? I think it is sum, but no, it is sum. There is, I forgot the name of the thing, but I think there is the same concept where you multiply. I forgot the name. Oh, there isn't enough arguments. Hmm. Oh, recursive multiplication. So this is what I was thinking. So it is multiplication. So yeah, it wouldn't make sense if I could just copy and pass. So how do I do it with recursive multiplication? It's just x and then times and then -1. Okay, is this correct or not? Okay, so when it's 0, it's supposed to be 1. Yeah, nice. I still haven't figured out, but linked lists are very hard for me, but I don't understand really well like exactly why. It's, it's very different than solving problems with arrays or anything that you can loop over. So it's the same with linked lists and trees, I think. But because I think arrays and other stuff, I have an intuitive way to approach the problems now. But these other ones is very hard for me, and I can't quite grasp like the core of the issue of why can't I think in a way that is gonna allow me to see the solution for linked list problems. But I think I am becoming better with recursion over time. It's a lot more intuitive now for me to think about recursion. Uh, the biggest thing is that uh, I think the biggest challenge to understand recursion is at the point that it reaches the base case on the first iteration, like it goes all the way down, and the backtracking part is really hard because you have to think about what is going to happen once it reaches the base case, and then it goes back the stack because it's going to go execute the rest of the function from that point. It's very difficult to think about like how to structure the function in the way that that backtracking thing is going to make sense. Let me see if I can solve. If I can't, I go back and read the stuff. Must implement the function remove by value, which receives a double pointer to the head and removes the first item in the list, which has the value. Wow. So remove by value. So it receives a pointer to a pointer of the head. Pointer to a pointer. So I think it's just looping over the linked list, but I'm trying to see to think what is the best value, what is the best way to do that. Yeah, I think here it starts to get confusing because of the double pointer for me. So the thing that I'm not like 100% sure is if I should like what is the best way to dereference. So if I should put this between parentheses and then put the pointer and then use the arrow to get the value, or should I do something else? And I'm not also not 100% sure if I should do a loop here or if I should do something else. So I think it's int I 0. I forgot how to do loops. It's obviously gonna be the conditioner, then I++. And maybe it's not with the loop. I have to access the value and then based on the value go over the next one. How do I do this? So what I'm thinking is like so I have to return the value of the one that was removed, I think. Oh, so yeah, it is that this is the way that I was thinking about doing, but I wasn't sure if I'm so maybe it's still wrong because I was thinking about doing the left hand side on right hand side. So you do reference the thing first. So like it's a malloc and the malloc is gonna contain a pointer. No, it is a pointer to the malloc and then the malloc contains the values, which is the struct. So in order to get the actual value, you have to do reference 2 times. So this one gets the place on the malloc that the node exists, which is the struct, and then that contains the pointer to the other one, I think, or the node, because the struct contains a pointer to the next. So the referencing twice to get the value. So this is going to be the struct of the next node. So I think that makes sense. So I guess you need to pass the nodes that you want to remove from this one. Yeah, it's freeing the head, which is the one that you pass. I don't understand really well this part here, though. It's like, how does it free first and then points to the other thing? Yeah. It's kind of hard to think. It's hard to visualize in memory what's happening when it calls this. So I think it's freeing, so it's like at this point is on the malloc. At the point head is on the pointer inside of the malloc. Then it frees that place, But then how does it, like, why does it point? I guess it is deleting the memory that the thing was pointing to, but I shouldn't use the, like, to, actually not, because yeah, I think it just removes the value and not the pointer. And then this updates the pointer to the next node. Yeah, so maybe if I use scale draw to draw what I'm thinking. Let me grab this. So I think that this is the malloc that contains, each one is gonna be like a struct that is a node. And this will be the head pointer. So like this is pointing to, this is actually pointing to the, so is a malloc? Yeah, but I'm not 100% sure. So what it's doing there is just saving the, let's do this one because it's easier. As far as I think, I'm not 100% sure if that's what's happening. But I think what it's doing is just deleting this stuff here. It's deleting the memory here, and then it's just redirecting this to the next one. But that wouldn't make sense. Because it has to remove this from here. So maybe what it's doing is just deleting this part here, the rectangle inside. Yeah, it's deleting this place, the arrow still exists. And then it just shifts the arrow to this one. So like next node is gonna be the value that the pointer is pointing to, I think. Which would be the struct. So it makes next node equals to this struct node here. Then it gets the return value. So what's confusing to me is this one. I think the struct maybe exists inside of the thing. That's what I'm confusing. Because the struct itself has the pointer to the other one. So but so I guess I have to understand the declaration here again. So this returns the pointer to the malloc. Then it makes the next. Yeah, so I think it's the other way. So just doing like separate. Initializes this, like the value of the test list is going to be a pointer to this, which is the malloc, and then each one is going to have a malloc as well. So the next of this one, so inside of the thing is the struct node, I think. And the next is the pointer to the other one. I think that's how it works there. And it passes the address of the first one. So I think what is passing to the functions is just the pointer to the head. Like the test list value, which would be this thing here. So passing the reference to the head. But I don't understand why on some of them it is like this double pointer. Also, link the new item to point to the head. So it's something that's why it's pointers. So like on some of them, you create a new value and then like you point to the head of the list. I think I understand now. So that's why you're dereferencing. So when you dereference twice, when you do the double pointer, you're gonna get the value here. Because you're removing this one and this one. So you get the node, which this one will be the head node. Hey, what's up? So the next nodes. Again, I think this is the confusing thing because I hear just the declaration that it's gonna pass the double reference, but I think here, like when it does this thing here, is just dereferencing one time. So like you pass this value here, and then the first reference gets this value here, and then the arrow is gonna get this value here. So the next node is gonna become this value, which is this node here. I think that's what's happening. Let me think. And they reference one time. No, because if you dereference one time, you should just get the pointer. Yeah, but then when you use the arrow, So the next node is a pointer. It should be the like this value, not this one. So it has the pointer to the struct. Which kind of linked lists are... I'm just trying to do this exercise here. So I think you have to remove the last item of the list. No, you have to remove the item that matches a value, I think. Sees a double pointer to the head and removes the first item in the list which has the value val. So like you're getting a value, I think. Like the function receives a value like this that points to the head, which is this one. And then you have to iterate over the list and check to see if the value is the one. And then you remove that node. So I think to remove you have to like change the pointers, but I'm trying to understand the other functions here that they provide. Because I think you're supposed to call them. So like when you get to the value, I think you're supposed to call this pop function and then pass the value of the current node. Linked lists are very confusing to me. And this is the one that I'm trying to understand. So it's gonna receive a node. And next item the head points to. And save it. Oh, remove the first item. Yeah, so I think that it is kind of confusing though, because I'm not 100% sure if this is supposed to be the like a value that points to the head or no, I think it is receiving. So the pop function receives a node. It's gonna be like receiving this thing here. So when you dereference twice, you're getting the value of the next node. I think that's what's happening. So you pass these nodes, you pass a node which is just gonna be a pointer. Then when you dereference the first time, you get this pointer, like you get this struct, which has the next. And then when you use the arrow, then you get the value of the next one. I think that's what's happening. Like here, and then you get the value here, same way. Then like you free the pointer to the head. So like what does this mean? Do you remove the arrow here? This part is the one that I don't know. Dereferencing the head. So I think you're freeing this memory, like, because you're dereferencing one time, so you're accessing this value here, I think, inside. Then you're freeing this value and making it equal to the next node. I think I understand now. So when it uses the pointer to the head, it just deletes the value inside of here, and then reassigns this value to the next one. Yeah, which it can reassign because it's saved here. I think I understand now. It's very confusing. So it's just gonna remove the node that you pass to the function. I think I understand. But you have to pass as a pointer to the... So it's just one level of the pointer. It just uses the double pointer because it's gonna access the other one, I think. I'm not really sure. I don't understand really well. Like, why it has to be the double pointer here? Because in my mind, you're just passing like the reference to this value. So it's just one level, I think. Like, unless the value inside of the memory is a pointer to destruct. But if that's the case, then the other part's still confusing. So I think this one is gonna be the value or the address of the malloc, as it is there. It's kind of confusing to me still. I'm trying to clarify in my mind. Like, why is a double pointer when in the declaration there? Like, is it because this is a this is a pointer to the malloc, and then you're passing the address to the pointer? But why do that? Why not just pass the pointer itself? That's the thing that I don't understand. Well, let me see. So I think the first thing that I have to do is check to see if the value... I have to, yeah. The value of the head is equal to the value that is passed. Then I have to remove the current node, I think. So I just passed I just call the other function. And pass the node. Maybe that's why it passes as a double pointer, because this one requires that. So I think the main point of confusion is that I'm not 100% sure if the malloc is gonna contain the struct itself or the pointer to the struct. I think I have to return the value. No. Double pointer to the head and removes the first item in the list which has the value. Wow. So now how do I loop over them? I think I just have to do the same thing that they do there, like here. So maybe this way makes more sense instead of checking for the head first. But then how do I think like from the constant level, the way to do is probably create a pointer to the node and then you move the pointer until you find the node. And when you find the reference and you delete, or you call the pop function. But I'm confused about the pointers and the places in memory. I think I'm just gonna leave this one here and think about how to loop. So maybe while and then I need to check, and then after I check, I just make the current equal to the next. So how do I think checking is just the reference again. Let me think about this. So I'm creating a pointer to the head, so it's just gonna be one level. And then I pass as an address, probably. I have to make here. But if I call the pop, I think I don't need to do this stuff here. I'm still. Let me run this and see what happens, but I'm confused about the pointers. 1, 2, 4. So I'm probably getting a segmentation fault on the last one. Hmm. Maybe if I put while current and current next, or while current, maybe while current. Hmm. I think I can't pass like this, probably. I'll try. Yeah. I'm probably gonna look at the solution, but I just want to spend a little bit more time trying to see if I understand what's going on. Wonder if Python tutor has something that it has C++. 'Cause it would be very good if I could visualize the arrows. So it does have C and C++. I'm gonna copy the thing they have there, and I'm going to see on Python tutor what's going on. So I'll be right back. Invalid, width of size 4. Oh, this is a different. Hmm. And maybe I just got the solution and then I look at the code. But yeah, I'll be right back. Then I'm gonna continue to try to solve this stuff. I'm changing my mind on lead code exercises. Maybe it's gonna be a good thing to try easy ones and then use Python tutor like to train pointers. The downside of that is that these ones are good because it gives you like a template or like a direction to start, so you kind of know like what is recommended. The problem with the lead code ones is that like I'm never gonna be sure if I'm developing the right patterns, let's say, because I can think about the solution at first and then maybe it works, but it wasn't the best way to do it. So that's the biggest downside that I see with the lead code ones. But this one I think is good because like it's forcing me to think about this stuff, especially with the linked list ones because like it involves pointers a lot. So the only thing that I wish was that this thing was slightly bigger, make it easier to look at the code. But uh, yeah, I'm gonna reset and then look at the code here. So that's how I was imagining, but let me think. So it is pretty much the way that I was thinking about it. So yeah, what I can do is just call the pop function with one of the nodes. The question is how should I how can I pass the function? Maybe if I just remove the heads, there is one. So there's an address that points to the pointer. Hmm. So I don't understand why It doesn't have anything here. So you should dereference once. Oh, because yeah, I guess this was what I was thinking before. This is the point of confusion. Because if it's the pointer to the pointer of the struct, then when it's dereferencing once, this one doesn't have next because it is not a value, it's a pointer. So I guess you need to pass you need to, but if you pass like the node, the pointer itself is gonna complain, I think, about the type. But I guess I can pass that. But maybe it's my job to change that as well. So put like this, and then just pass the node. I'm gonna try that. If it doesn't work, I'm just gonna see the solution. Oh, maybe I forgot to... No, I did assign the value, I think. Here. Current nodes. Because then it would complain, I think. Yeah, so probably. But if I'm understanding incorrectly, then why this Python tutor? Obviously, I'm missing something here, but it's just confusing as fuck. The order of the arrows and figuring out what is on each thing. Now I'm supposed to be passing the pointer to the thing, to the place in memory. So when you did references, in my mind, it's supposed to get this struct that has the thing. Yeah, but yeah, so I think it's not gonna change anything because like I can change this to the dots, but then I think it's just gonna be the same as the other, as it was on the other way. So the problem has to be on somewhere else, I think. But I don't understand why Python tutor like is complaining there. Maybe I'm missing something. Let me like check again. So it creates everything. It's pointing to each one is pointing to another malloc on the next. So next is a pointer. Then I'm passing the address of the pointer. And so the head is the pointer to the pointer. So it did references once and checks to see if it's no. So checks to see if the pointer is no. So as far as I understand, I think that the no pointer is just a pointer that points to a null value. So, but I'm not really sure if the no pointer is gonna be like if this condition here. How can I ask this? I wanna understand if the condition there to make the pointer equal to no is it works to check if the pointer is no. What is it checking? Is it checking the pointer itself or where the pointer is pointing to? I think it's checking where the pointer no. Because the issue is that it is a double. So let me. So it does check the. So if the pointer points to a new value, the value of the pointer itself is gonna be null. This is the one that I don't understand. Because like I get what's happening, but I don't understand how it works on the other one. Because it has a double pointer, like this is passing this thing here, which is a pointer to a pointer. Then on the first time that it references, it gets this one, the task list. But then the task list is a pointer, it doesn't have the next. So you can't dereference to get the other thing. That's why I thought that it would make sense to pass the thing itself, because then on the first dereference it would get this one. And then it makes sense to dereference the value of the next, because then you would get this struct here, which would be the next. But I don't get why on the other one it works. I'll try with the dots now. Should be the same thing. So just remove the thing and make this close here. Yeah, so it's the same thing pretty much. Just changing the which one I'm passing. The thing is, I think I'm not supposed to change this function, otherwise we'll probably have a comment there, so I don't understand. It has to be because I'm passing the wrong thing, so let me go back to the way that it was before. So this one also weird because it works. Like this should be breaking as well. Maybe the arrow dereferences before it accesses the value, that's why. So the first time it gets the pointer, but then the arrow dereferences. But or maybe it's actually because it's a malloc. But it would be the same thing. But so I think that the arrow dereferences first. Okay, first it references the pointer, then it gets the value. Yeah, that makes sense. So yeah, never mind. But I don't understand why it isn't working here then. It is supposed. It's probably because of the way that I'm passing. Yeah. Yeah, because it should pass as. I passed the wrong way, I think. But let me see if it's gonna complain. So it does complain about the no check. Hmm. So it can't be the way that I'm passing. It should be the address, but then it messes up. think I'm gonna try to change to the dot there instead of the arrow, see if it works. Actually, I have to dereference twice if it is what I'm thinking about. So but I I try to do the double arrow, the double starting, but you complain that about the arrow, so I don't understand what is going on. Because I was doing like this, but then with the arrow, and it complained, so it should mean that this, like when you dereference twice, is getting the value. So that should mean that if that's the case, then the arrow shouldn't work on the previous one, or it should work if it is dereferencing before it accesses the value. Oh, maybe it's just this thing that is wrong, but what if I try? It's probably not gonna work though, like this. I think it's just gonna be the same thing. Yeah. Oh, so it still checks. Or maybe I should use the dot instead of using the arrow. Oh, but so I think up to this point, I had the correct vision in my mind of what's going on. So the value should be 1. So it's not gonna go there. So this one I don't understand. Because I have the pointer. So I should dereference first, I think. Yeah, that's the problem. I think. Not really sure. If I put the dots, it doesn't make sense. So let me go back, visualize again. So current node is this. I think it's just the pointer of the head. Because this one is pointer to pointer, so it's pointing to this. And so I guess the question is, how do I dereference? Yeah, but it should be working, I think, in my mind if I do the what I try to do there. Because like I'm dereferencing this first and getting the value, and then get access using the arrow to get the actual value of the struct of the next. Mm. Oh, so I think I should use the arrow, then use the dot to access the value, which is gonna be a pointer, and then I dereference. So I do like this. I think it's confusing me because the next is the pointer. So this access the value, which this thing is gonna be the pointer, and then I dereference this stuff. Let's see if this works. Incompatible. Yeah, because this has to be a pointer. So maybe if I just do the like this should work. Yeah. So like it's complaining because I initialized the thing as a pointer to the struct, not the struct itself. I'm still giving this thing here. Yeah, because I guess it's the same thing, like I'm just doing the same thing. So the question is, why is it showing this thing here if like this does have a pointer? That's what's confusing. But maybe it could be just a Python tutor thing. Because if this was no, then also this shouldn't be passing, I think. Like the condition. I think it's just a problem with Python tutor. It's kind of confusing. Because if this was unallocated or misaligned data boundaries. Hmm. So it doesn't necessarily mean that it doesn't exist. It means that the is unreliable. And so I think like what I have to figure out is how should the reference is like this is gonna be the pointer, not the thing. So what I was thinking is getting the struct and then getting the next, obviously. But I don't understand why when I use like this and then I use the arrow, it doesn't work. Or maybe it's complaining because of the type. So let me try it the other way. So like doing like this and then getting the address. Yeah, not. It's probably not gonna work. 'Cause I do think it's complaining because of the arrow. So I'm trying to access the value. Because this is the pointer to the head, and I'm trying to access the value, which is the struct. Yeah, but then it should be like it's just gonna complain. Then it's gonna be the same thing as using the thing. Because next itself should be, if I access the value of the next, it should be a pointer. If I just do like current dot next instead. Hey. Yeah. So like this should be returning the pointer though. Don't get it. I think I'm just gonna spend some like a little bit more time and then I'm gonna look at the solution. I'm trying to force myself a little bit to because that's the whole point, obviously. But I think I reached the place that I don't know like which direction to go anymore. Because it's just showing this thing here, but I don't understand. So let's see. It builds everything. So current node is the pointer to this thing. Because I'm dereferencing. This is another kind of complicated thing to understand. So, but it's hard to formulate a question about this. Like, because what I'm imagining in my mind when it has a star here is that like, it's gonna remove one of the arrows, right? So head is this thing here. So when I put the star and the head, it's gonna remove this arrow and it's gonna become this thing here. But I guess it is this thing because of the address is the same. It's just the visualization is kind of weird. So I think it is correct. It's just that the visualization is kind of a little bit misleading. But it's understandable that it is this way, I think. Because if the arrow is to the address here, then it might be kind of confusing. But I think that this is what's happening. So the current node is just the same address. Because what you're actually doing is just creating, like you're putting the address of the thing on a different place in memory. I think that's why the arrow is not there. So I think that makes sense. So current node is supposed to have the same address that the head node has, which points to the struct, which is going to be the malloc on the heap. But then here is the place that doesn't make sense. So I guess one question I can ask is, does the arrow reference the elements? Or I think that's it has to be this way. It's the only way that makes sense. Yeah, I'm not even gonna ask this because I know it is. Because of the other way that you can write using the star operator. So I think it dereferences first and then access the value. So if that's the case, then you should like dereference first, which is getting this value and removing the arrow, and then accessing the next, which is going to be a pointer. So I don't understand why it's saying that it doesn't exist here. Like it is giving the emoji thing. Oh, but it is showing the address now. So I guess it's just a Python 213 probably. So it's probably correct. So now current node is gonna be this struct. Oh, maybe it's because of the type actually. Yeah, because the type is a pointer. And now I made it equal to the thing. So maybe if I, but I think I didn't try the correct way probably. But hmm. If I do it like this, but I think this is not gonna work as well. So probably the biggest thing to clarify that I'm very confused now is the difference between using the operators on the left or right hand side and the ampersand and the star. This warning is kind of confusing as well because isn't this supposed to be a pointer to the thing? To node D instead of the struct? Oh, so it's saying that I'm getting the value. Oh, so this returns the pointer. So this is the pointer because it's the next, and the next is the pointer to the other. So I guess that it was correct the other way. Because the next is going to be a pointer. But obviously still weird that shows the school there. But I think it is showing the correct address, so... Well, maybe it's because I have to put the star on the other side. So... But I don't think... let me see. Like if I do like this... Yeah. Like maybe it's giving the school because I'm just putting the place in memory, but it doesn't point to anything. Like I have to copy this. Let me continue the execution, then think about it more. But I think the issue is that I'm creating like I'm making the current node equal to the address, like equal to the next node, which is a pointer, but I'm not creating a new pointer, if that makes sense. But I'm not really sure if that's the problem. Because on this one, it seems like it does get there. So, yeah, but if I don't pass the address, then it's gonna complain. So I don't know, I think it's just a Python tutor probably thing. And it is working. But then for some reason on the other ones it doesn't work. Oh, it's probably something wrong, but I don't know how to like how to think about this, how to make sense of this. Because it makes sense on my mind. So like I have to think about how to formulate a question that is gonna help me clarify because I don't understand what is wrong here. But it seems like there is something wrong with the way that I'm doing this. But in the way that I was thinking before, it seems that it is right to me. So I think that it comes down to the stuff that I was saying, that I'm making a variable equal to the address of the next, like equal to the pointer, which is equal to the next, which is a pointer. But I'm not creating a new pointer to the struct. So I should be moving the struct. So I should be moving the arrow on each iteration instead of making it equal to the thing. But I'm not really sure like how to do that. How to go about doing that. Because if I use the if I use the ampersand or the star on the left hand side, then I think it's just gonna complain that I'm accessing or reassigning the value, and it's gonna complain about the type. And so the question is, how do I move the pointer each iteration? But the thing that is confusing is because it shows the same address that it has here. But I think that's the thing, is like, because I don't want to create a copy, that's the thing. One thing that I can do is just start with a new another value, and get the value and then loop over the values. But I want to understand. So maybe the question I can formulate is how to update the pointer. Fuck. And so it's recommending the same thing that I'm doing. So let me continue and see like what is the warning, or why is it fucking up. So let me go back. So I think I'm at this point here, and then I pass these nodes. Hmm. I I, I think my intuition is right, but I don't know how to go about clarifying this. Like the problem is like the way that I was imagining in my mind is moving the arrow, I think. Like the way that I was imagining is like moving from one pointer to the next, and then I just get the values of that pointer. And if it is, I pass that thing. Or I pass the reference to the thing, because then I can dereference twice on the pop function. But I think what is happening is that because I'm making it equal to a variable, I'm just passing the address to the other variable, and then like it creates something that I don't really understand very well that fucks up this function here. So it's very confusing. So I think this is another thing that I had wrong in my mind. That's because the way that I imagine is always as if like I'm replacing the value that is gonna be passed to the function with the whatever it is here. But I wasn't imagining in my mind that it would create a new variable like it is here. And then use the new variable that it creates. So this is one of the things probably that's is like a bad habit that I got from because I learned with JavaScript and Python. So I always imagined as replacing the value that I'm passing to the function, and then the function use the same value. But in reality, what happens is just copies, even if it is a reference or a pointer. Just creates a new variable, and then that variable is going to be the pointer. So I think that this creates a pointer to this, which is a pointer to this node here. Yeah, because the address is the same. I think that this is what's happening. Then on this one, you should dereference this and then access the next, which is gonna be this one. So it should be like the next node should be this thing here, the pointer to the other one. Oh, so I guess that this doesn't check to see if it is no. But I guess it doesn't matter because you want to remove the current one. So the value is going to be the same thing. Then when you freeze, it removes that. So the problem has to be on this one, I think. Oh, so it looks like it is updating. So I think that is not completely wrong to think the way that I was thinking, that like it's just gonna replace the value, but it's slightly different because it creates a new value in memory to serve as a template, I think. Based on the way that this is showing here, obviously. So it does make sense to think about as if it is gonna replace whatever value passed to the function with this. But it's slightly different because in reality it creates a new variable like that serves as a template, a template or a template holder, and then through that template it's gonna change the actual value, I think. So like I don't see what's wrong with this one. But probably this is not the one that it is messing up. So it looks like this one is correct. Oh, I'm not returning. Maybe that's the problem. So maybe that's the issue. So when I pop, you should return. Yeah, but I think I was doing like that the last time and it didn't work. On here should return as well. Yeah, it's still messing up. So I guess I'm just gonna look at the solution, spend enough time. Oh, this is another thing that I wasn't checking. So this part is correct. So it's caching both the previous and the current. Oh, so it's not using the function. I thought I was supposed to use the pop function. So while current. This part's the same as the way that I was doing. Oh, I think it is the same because I'm just getting the difference is that obviously I was using one variable, they're using two. So it's just freeing the memory. So I guess look, the way that I was thinking was correct, but I still don't understand why. The kind of the logic, not obviously on the thing, otherwise it would work, but like the nuances, but the logic of the concept of the way that you do it, I was thinking correctly, but I don't understand why when I did that it didn't work. Like what was wrong with the function? So like why I was getting a segmentation, but I'm not really sure if I can. Yeah, I don't think I can look at the like the test cases that they put. Maybe just the print list. So it could be because I wasn't, but it wouldn't make sense to have to update the value. I don't think that makes sense. Yeah, I don't know. I think I'm gonna stop streaming here. Spent a bunch of time already, and I'm gonna continue to read these books here. Like there's a bunch of stuff that I'm learning, but I think it is good to do these exercises because it forces myself to think, and I'm gonna try to see if I can clarify this stuff off stream. Because now I'm curious to know, like, why the way I was thinking here it doesn't work. Why do I get the segmentation faults there on the other one? But probably not gonna be able to because I can't see the tasks. So I'm probably gonna spend a bunch, or not a bunch of time, but some time. And what I might do is just try to do lead code problems soon while I read all these other books because I think it's gonna take a lot of time to finish everything. So I could do like try to do easy lead code problems, and then the lead code ones is better because then I can look at the solution and like see why it didn't work. I guess the other thing that I can try is just put the code on the IDE, like create another project, put the code, and see what happens. Like why I'm getting the segmentation faults. So probably what I'm gonna do is just create another folder, another project, just to do these exercises. And I'm gonna finish all the other books first before I go back to the pointers by Kenneth, I think, whatever his name is. And then once I read that one again, I'm gonna put the like all the exercises on the project as well. And so the idea that I have is just finish these books and then continue to do some exercises until I get it. I don't have to think about the pointers anymore because I understand like intuitive level how it works and what I'm supposed to, like the main patterns. Once I have that down, then I think I'm gonna move on to building the compiler, the graph from the compilers in C++, and hopefully go back to the browser at some point. But I'm thinking now more about continuing with the project in C++ mainly, because the best I'm not obviously not sure, because like it can be, there might be a bunch of different roadblocks that I'm not really aware. But the good thing that I think about doing on C++ instead of doing in the browser is that I don't have to think about the state management of the website and React cycles. So I can just focus on the graph itself. And the other great thing about it is that potentially it's going to be a lot easier to integrate with the IDE. So I think it just makes more sense. But I'm not really sure if I'm going to completely stop the browser version. I think I'm going to try to do both of them. So the browser can be like a very simplified version. So just so people that can understand how it works. And then the C++ one that I'm going to build locally is going to be the one that is more advanced, because it's going to allow me to just focus on the graph itself. And that's what the point I want to get at. But it's going to take a bunch of time. So I think that while I do all this stuff and read the books, I'm probably going to try to do easy lit code problems with C++ just to become better at using pointers. So probably tomorrow I'll come back, or 2 days from now, then just to expand it. And the way that I'm gonna do is just half an hour, I think. So half an hour for a problem. If I can't solve, I just look at the solution and then I try to see what went wrong. And I think I'm gonna create a project locally as well, like set it up so that I can go with VS Code and the debugger to see on the solutions that doesn't work, try to figure out what I'm doing wrong. So probably gonna do that next time. So yeah,